Hello students, welcome to AcadShala.
You will achieve success. You will be the winner. You will achieve the ladder of success through learning, training, instruction, practice, and then you will have the key which will unlock the door which is going towards success. Today we are going to study Part 2, Electricity, which is bright and beautiful.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
Over here, students, you are seeing 3 pics of the renowned scientist. The first one is Benjamin Franklin. Benjamin Franklin in 1752, what he did, it was thunder and lightning going on outside. He flew kite and tied key with silk thread and tried to fly this kite in thunder and lightning atmosphere. The key came back and got shock. That is, because the key was made up of metal, it got charged. And hence this scientist got shock. That means his work field was based on charges and static electricity. The second scientist, Nikola Tesla, his work field was on the basis of AC, which is known as alternating current. This scientist was a student of this scientist, Thomas Alva Edison. This scientist's work field was on the basis of DC, which is known as direct current. So this was a little bit brief, that is the history about these scientists. Oh my God, what is this blackout? I can't even imagine without electricity, not at all. We are so dependent on electricity that I can't even imagine it. Electricity is a source of energy that has made all life comfortable and easy. We depend on the electricity for almost all activities in our day-to-day life. Electricity is used to glow bulbs and tubes, to heat electric iron, to heat water, to operate refrigerators and ACs, and to run electric trains, and so on and on and on. There is hardly any field where electricity is not needed. Its importance can be felt at once when the electricity supply of our city breaks down. That is why I was surprised over here seeing out the blackout. So with this, we have come to know the importance of electricity, which plays a vital role in our lives. Okay. Now children, if we study about electricity over here, we see the word that is electri. Only the word electri, which is written over here. What do you mean by electri over here alone? Yes, students, absolutely correct. It is known as electron. So that means, and the city, this together is known as, that is, city of electrons, known as electron city. Now, this total electricity means what now? That is flow of charge. Flow means motion. That means the flood of electrons together going on. So, flow means motion. That is electron flow. That is why we say electricity. Electricity is a source of energy that has made our life comfortable and easy. Now, students, if I ask you that I have an object, but it does not have mass, and I ask you what does it mean? You will say, ma'am, that means the object does not exist. What do you mean by this, that the object does not exist? That means the amount used to make an object is zero, absolute zero. That means the object does not exist because the amount used is zero. That means we can't even see the object over here because there is no amount used to make it. Okay. Now over here, if I say this is the ball and ball is made up of rubber. What do you mean by this? And if I ask you what is the mass of the ball? You will say, ma'am, mass of the ball means that is the amount of rubber used to make a ball is only the mass of the ball. Absolutely correct. So you have understood the difference between the two, children, that if I say an object does not have mass, that means the object does not exist. Amount used to make an object is zero. If I say that ball is made up of rubber, what is its mass? You will say, ma'am, amount of rubber used to make a ball is only the mass of the ball. So I've repeated intentionally to make the difference between the two, to make the clarity what the wordings are saying. Okay, children, next. Now, children, you must have heard about fundamental property of matter, which is known as mass. Yes, children. Now, what do you mean by charge then? Charge is also the fundamental property of matter, which is exactly what you hear it, what you do it about mass, because mass is also a fundamental property of matter. One of the fundamental property of matter is mass, as well as one of the fundamental property of matter, the charge is also there. So every matter is also having charge. Always and always remember, children. Next. Now the charges are of two types, children. Positive, negative charge. Now, children, if you have seen in chemistry an atom. Yes. In an atom, in the center, we have nucleus. And in the nucleus, we have protons and neutrons. Correct, children? And these protons and neutrons collectively are known as nucleons, which is there inside the nucleus. And around the nucleus, we have electrons, which are negatively charged. So, electrons are negatively charged, protons in the nucleus are positively charged, neutron in the nucleus are neutral, that means no charge. All these three, that is electron, proton, neutron, are known as subatomic particles, which we have studied in chemistry already. Now, children, if I take a magnet, you know, magnets have two charges, that is positive and negative, at the ends. So, if I take two magnets and this magnet is having negative charge, another magnet is also having a negative charge, I try to put them together, but they go far away from each other. That means they repel each other. And if I put the charges opposite two magnets, I have kept it over here with the opposite charges. So what will happen? It will attract each other. So this is all about the charges we have understood in this slide. Now, next, how do we say that an object is negatively or positively charged? This is the big question mark, children. Yes, we need to understand this. Now we know all about subatomic particles. We have studied in chemistry too. And just now also I have briefed about the same. A body is said to be negatively charged if it gains electrons. Absolutely correct. A body is said to be positively charged if it loses electrons. Absolutely correct. So these two things we have understood. When it gains, what charge it will have? When it loses electron, what charge it will have? Absolutely correct. We have understood this. We also know about an atom, which I told you just few minutes back. And in chemistry also we have studied in detail. Now let us understand how a substance acquires electric charge on rubbing it with another substance. A substance consists of atoms, which I already told you. Each atom is electrically neutral. What do you mean by electrically neutral? That is, net electric charge on each atom is zero. In fact, atom consists of protons, which is positively charged, and equal number of electrons, which is negatively charged. Hence, net charge on an atom is zero. That means when positive and negative are equal, so the net charge on an atom will be zero. This is what it is trying to tell you. The positive charge, which is known as protons, are tightly bound in the nucleus of an atom, which I told you just now, few minutes back. Negative charges, that is electrons, revolve around the nucleus in different orbits, as you are seeing over here in the diagram. The electrons in the outermost orbit, that means this one, this electron, which is away from the nucleus, the electrons in the outermost orbit are loosely bound to the nucleus as compared to the electrons in the inner orbits. That means the electrons which are away from nucleus, they are loosely bound, and the electrons which are very close to the nucleus, that means what happens? They are not loosely bound, they are means intact with the nucleus. Clear, children? Okay, next. Now, over here in the diagram, again you are seeing an atom. Now, when a substance is rubbed with another material, the loosely bound electrons are removed from their atoms. This is what I told you just now in the last slide. These electrons are transferred to the material with which the substance is rubbed. Absolutely correct. Now the atoms of substance losing electrons do not have equal number of electrons and protons. Of course, when it will lose electron, of course, there will be a change in the number of electrons. These atoms have more protons. Of course, when this will be lost, so the number of protons will be more than the electrons, which is negatively charged. Hence, the atoms losing electrons have net positive charge and called positive ion. Absolutely correct, which I told you. On the other hand, the material to which free electrons are transferred has net negative charge. Therefore, when a glass rod is rubbed with a silk cloth, over here, with the silk cloth, what? Glass rod is rubbed. Then glass rod loses electrons and hence has a positive electric charge. Okay. On the other hand, silk acquires those lost electrons and hence has a negative charge. An object or a body losing electrons is called positively charged body. Absolutely correct. On the other hand, a body gaining electrons is called negatively charged body. So I repeat, children, when the electrons are lost, it will attain a positive charge. When the electrons are gained, it will attain a negative charge. Opposite of maths. The mass of positively charged glass rod decreases and the mass of negatively charged silk cloth rod increases. The decrease in mass of positively charged glass rod is equal to number of electrons lost into mass of an electron. The increase in the mass of negatively charged silk cloth is equal to number of electrons gained into mass of an electron. And the charge over here is denoted by Q, which is small q, or capital Q. This you need to understand very well, and this is very important for the numericals, which will be doing it in coming up videos even. Okay. Now, you all have understood about the charge. I have been telling you about charge. What do you mean by this? I have told you elaborately. Do you also over here elaborated the same? So, it is a property of matter by which it attracts or repels other material. This you have understood? Just now I told you it is denoted by Q, and SI unit of This is C, which is known as Coulomb. Now, what do you mean by this? 1 Coulomb is very huge charge or unit. And it also has small unit of Coulomb. What it is? It is Millicoulomb, which is denoted by small m and capital C. Another one, Microcoulomb, which is U and capital C. This is the way it is written, children. So you need to understand how to write and what do you mean by small unit of Coulomb. This is very important for your numericals in coming up videos. Now, what is the value of Millicoulomb? 1 millicoulomb is equal to 10 to power minus 3 coulomb, and 1 microcoulomb is equal to 10 to power minus 6 coulomb. Now, we also should know the value, that is charge on 1 electron or electronic charge is equal to 1.6 into 10 to power minus 19 coulomb. This, please, you should note down the values of millicoulomb, the values of microcoulomb, and the value of, that is charge on 1 electron, which is known as electronic charge, 1.6 into 10 to power minus 19 coulomb, which is really very important. Again, I'm telling you for numerical. Okay. After this, you must have heard about the word quanta. We are going to study about quantization of charge, which is really very important. You should know it. Now, when I talk about quantization of charge, I have also heard about the word quanta. Yes, quanta means, children, packet. What do you mean? Packet. Now, children, I would like to ask you, when you go in a market, for example, and all of a sudden you're going with your mother, all of a sudden, of course, whenever you're going in a market, so you feel like eating something. Yes. So you demand from your mother, for example, that I want to have bananas. I want to eat bananas. Okay. Your mother will say, okay, how many bananas you want? You will say, Ki mama, I want 2 bananas or 1 banana or 3 bananas or 8 bananas. But you said, mama, I want 1.5 banana. I'm hungry for 1.5 banana. So your mother will be surprised and asking, what is this? What are you asking about 1.5 banana? Either you take 1 or 2 or 3. What is this half you're talking about? Nobody will give you half banana. If I will say give 3 bananas, the shopkeeper will give 3 bananas. If I will ask him to give 1.5 banana, of course, he will deny. He will say, not at all, ma'am, I cannot give. I will give either 2 or 3 or 8 or 1 if you want, not 1.5 banana. So it is not possible to get it like this. Are you getting my point, children? Either you will have 1 banana, 2 banana, 3 banana, but not in between 1 and 2. The in between bananas you will not get. Similarly, we will be talking about something now further. Before that, I would like to ask you that now you tell me about smallest charge. Smallest charge is of, hurry up, tell me. Yes, electron. Absolutely correct, which we did just now. Yes, absolutely correct, students. Now, if I say 1 electron is equal to, that is the charge, 1.6 into 10 to power minus 19 coulomb. Yes, you have written. Then I say about 2 electron. Yes, you can tell about 2 electron also. Multiply with 2, you will get this answer. Then 3 electron. Then again you will multiply, you will get this answer. Now what is this value coming out in between? This is not possible. Next to impossible, does not exist. What do you mean by this value? Recall, children, I told you the example of bananas. That the boy was asking for 1.5 banana. His mother said, you will have either 1 or 2 or 3, not in between half. In between 1 and 2, the half thing is not possible. Nobody is going to give. Either have 1 banana or 2 bananas or 8 bananas or 5 bananas. Yes? Similarly, children, just I wanted to make you understand this is what it is happening over here. This will not exist. Either you will have 1 electron, 2 electron, 3 electron, 4 electron, and so on, but not in between 3 and 4, something half, as related with bananas, which I told you, taking an example. So sometimes in the numerical, this value is given, so no need to understand this. So this value, if it is given, so it is just merely to make the numericals done. So, but you should understand that the values between 3 and 4, nothing is in between the half of the thing of anything. Clear, children? Now, after this, after 1, 2, 3, and 4, in between, nothing happens. Then going on and on and on, you have Q is equal to NE is equal to N into 1.6 into 10 to the power minus 19 Coulomb. What does it mean, this Q? That is, Q is known as the maximum charge or the net charge. I repeat, this Q is known as maximum charge or the net charge, and its formula is N and E. E is what, bache? E is electron. That is this charge of an electron. And how many electrons? That though you will come to know when we will do the numericals and all. So this charge is nothing but it is the property, that is the quantization of charge is nothing but it is the property of charge. Therefore, charge also has a property called quantization. So, you should understand this, all children, about the values which plays a vital role in the numericals to come. And the example which I've given of bananas, it relates with this, children, to make you understand about the electrons. So, this is known as quantized charge. So, this is known as quantized charge. So, this is very, very important, children. On and on, please rewind the video and try to understand this. Okay. Now, suppose if I take one, numerical to solve, to make you understand, that is, suppose a body has 5 electrons. Okay. So, net charge I want to calculate. Fine. So, what is the formula to be used? Just now I told you, I made you understand this about this net charge. So, the formula for this is, that is, Q is equal to NE. And what is N? That is the number of electrons. And E is what? The charge on an electron, electronic charge. So, we will quote the values as it is given. So, I will write Q is equal to, that is 5, because in the numerical it is given 5 electrons. I have written 5 into this electron charge, electronic charge, 1.6 into 10 to the power minus 19. I know it because this value you need to learn it, children. Very, very important. You will solve and simplify. You will get this answer over here. That is 8 into 10 to the power minus 19 Coulomb. So, this Q is known as net charge. This N is equal to number of electrons, and this E is known as electronic charge. So you need to understand the formula, the values, quoting the values in it, simplifying it, getting the answer. And what does it indicate? You should know it in detail. So this way the numericals will come. We will take up many numericals in the next video too. So till then, please keep on revising whatever I have done it in this video and keep on sharing the AcadShala link. So with this, I wind up the session, children. Happy day. Bye-bye. God bless.